There, today we're going to talk about discontinuities on functions. So what is a discontinuity? Simply put, a discontinuity is a location on the graph of a function where one of two things will happen. Either the function does not exist, or the function isn't where you expected it to be, and we'll look at that on the next couple slides. Before we do, there's a little bit of notation here I want to show you. This is x with a big long arrow pointing to the right, and this means x approaches, or in other words, as x gets closer and closer to some number, or some value, or infinity. And then this y arrow means y approaches. So often we'll say something like, as x approaches infinity, y approaches, and then put a number or an infinity symbol or something else to that effect. All right, let's look at discontinuities. So on this page here, we're going to look at what are called point discontinuities, and I'll just zoom in a little bit so we can actually see what's going on. A point discontinuity is a point on the graph where there's either a hole in the function, which means the function is missing. There's a little gap at a certain point on the graph. So as x gets closer and closer to this value a, the function looks like it's going up to this height here, but when it actually gets there, there's nothing there. And the same if we look at it from the other direction, as x approaches a from this side, we can see the function looks like it's going towards that height of L, but when it gets there, there's nothing there. So that's called a hole. Same over here, as x approaches a, we can see that the function looked like it was going to be at a point L, but when it gets there, it's not there. And in fact, it's somewhere else. So it's somewhere you aren't expecting it to be. It's jumped up to here, to this spot. Instead of being where we thought it was, it jumped up to over here. So that's called a removable discontinuity, and it's when there's either a point missing or the point is somewhere where we weren't expecting it to be. And if we scroll down, here's another example. This is called a jump discontinuity. Here, as we go along the x-axis, as x approaches a, from this side, we're expecting our function to be at a height of L, but it's not there. And then if we approach a from the other side, we're expecting our function to be at a height of m, but it's not there either. But the function has a big gap here. This is like a gap in the graph. We thought it was going to be going towards this point L, but all of a sudden, whoop, there it is up at m and going upward. So that's called a jump discontinuity. And the third kind of point discontinuity is something like this function here. This is a square root kind of graph. It has a discontinuity in the fact that it ends at this point and doesn't continue. So it's like it starts at this point here and then continues on this way, but if we look at it from approaching from the other direction, as x gets closer to 0, the graph just ends right there. So those are three types of point discontinuities. Let's look at now an infinite discontinuity, and these ones you've studied in grade 11. These are called asymptotes, or vertical asymptotes. So these ones here, as x approaches the value of the discontinuity, the function either approaches infinity or it approaches negative infinity. So the function doesn't just disappear, it heads upwards towards infinity, gets taller and taller and taller as it goes, never actually reaching infinity, of course. And then actually, though, at the value a, the function doesn't exist. There's this gap in the graph. It's kind of like a big brick wall, and the function's going to get closer and closer to that wall without actually ever reaching it, and it's going to be reaching up towards infinity as it goes. And it does that from both directions. You can see sometimes the function approaches infinity on both sides of the wall. Sometimes it approaches infinity on one side, negative infinity on the other, and sometimes both sides approach negative infinity. So in this case here, for example, we could say as x approaches a, y approaches infinity. So that means as x gets closer and closer to a, the height of the graph gets closer and closer to infinity. And the last kind of discontinuity is when we have a spot on the graph here, for example, at the value 3, where on one side the function's approaching infinity, and on the other side it's approaching a value, but when it gets there, there's nothing there. So we've got a point discontinuity from the right side of our value 3, and from the left side of our value 3 we have an asymptote, or an infinite discontinuity. So since it's two different kinds of discontinuities in one, we call that a mixed discontinuity. Now you're going to continue on and try some questions.